Hello my friends, welcome back to a new video. Today we have something cool to show you, the Sentinel board. It's a new board with an ESP32 microcontroller designed for environmental monitoring and IoT applications. We took all awesome things we learned in our past videos and squeezed them into a budget-friendly super board. It's like the Swiss Army knife of Arduino compatible boards for sensing projects. But wait, there is more. The Sentinel's got a runtime clock, to keep time, a SD card slot for all your storage needs, an auto power circuit, fancy right, and even supports batteries. How cool is that? In this video, we will break down the Sentinel's design, show you its pinout, give you a peek in its first test run, and even use it in an underwater pressure and temperature logger. Get ready for some fun. So grab your popcorns, sit back, and let's get this party started. Every time I start a new project, I'm faced with the ultimate question: which microcontroller board should I use? One of my go-to choices has been the M0, whether it's the mini version or the Feather Ada logger that comes with a built SD card and a battery support. But no matter which one I pick, I always end up with needing extra stuff, a bunch of components like RTC, auto power circuit or SD card, and they are almost always the same. That's when I had a light bulb moment. Why not to create the perfect board adapted to my needs using the ESP32 microcontroller and take advantage of its awesome wireless capabilities? And that, my friends, is how Sentinel concept was born. The game plan is pretty straightforward. I'm gonna combine a ESP32 microcontroller with a RTC, a DS3231, an SD card holder and an on and off power management circuit, and all in a single board. To keep things tiny and cost-effective, I will skip the serial converter and USB port. Instead, I will use a budget-friendly USB to serial converter to programming the board. It's all about saving space and cash. We'll aim to keep the layout and dimensions similar to those of a commercial available ESP32 board, so it's familiar and easy to work with. I used KiCad to whip up the circuit diagram, and let me tell you, it was quite complex to squeeze all the components in. But hey, life is modular, and so are circuits. Our nifty Sentinel has a bunch of modules, like the microcontroller, the power regulator, SD card holder, RTC, auto power circuit, and a tiny voltage divider to keep an eye on battery levels. I have used labels to link everything together, keeping it neat and tidy. Most of these components were a breezy to work with. But the auto power circuit, that was a whole different ballgame. Usually I will just buy something like a Pololu 2808, but for Sentinel we have to create an analog logic circuit from scratch that could handle all our needs. We wanted it to power up the device when the RTC alarm goes on, turn on when a specific digital pin tells it to, and switch on and monitor when a mechanical switch is closed. So how did we pull it off? By combining transistors, a diode and a P-channel MOSFET. But hey, I know you are not into nitty-gritty details. If you want more info, feel free to pause the video and take a closer look. Let's keep the ball rolling and move on designing the board. Brace yourself, it's about to get complicated. And voila! Here is the final layout. Now, I'm sure that some electronic engineers might spot some flaws. But hey, to my untrained eyes, it looks like a masterpiece. And of course, I have plenty of time to work in this project, and I didn't forget to create a pinout using the renders, so we know the basic layouts and functionalities. The design closely resembles commercially available boards but has some extra features. The additional pins allows you to manually switch on the circuit and activate a digital pin to keep tabs on this manual action. And guess what? I have made all the pinout and all the code that we will be testing available in the GitHub repository dedicated to this project. Handy, right? Alright, time to assemble this bad boy. First, we need to order the components and the PCB. Lucky for us, PCBWay is on board to support our video, so let's go ahead and order some boards and stencils from them. Their platform is super user-friendly, and the quality of their board is top-notch. It looks fantastic. Now comes the fun part, soldering it all together, and I will be using my trusty custom hot plate for the job. So that was fun. Now here is Sentinel. Love to solder like this, it gets everything tidy and nice. As you see, the dimensions are quite similar to a commercial ESP32 board, so are the pin distribution, but with a bucket of Arduino compatible functionalities. The limit is our imagination. With this board we have in our hands a full data logging system with time tracking, able to download data wirelessly, as well as configure it. But let's not just talk about it, let me show you how it works with a test case. For the test, we will need a Sentinel, a battery, a reed switch, a sensor, in this case a digital sensor that combines the ESP32 for humidity and temperature and the BMP280 for pressure and temperature, and a magnet, because who doesn't love magnets? Connecting everything together is a breeze once the pins are soldered. Just hook up the battery to the corresponding pins, the reed switch to activate the board to its respective pins, and a digital sensor via the E2C connection. Now it's time to try it out. We will just need the basic code we developed in our previous video about the SD management with the ESP32. Check the video link to dive into the code. Once we unload, our data logger with the sensor is up and running. The SD card will store the configuration files that defines the periodicity of data storing, along with the files that will store the data. To download the data, we will simply activate the board with the magnet, and the Wi-Fi network will be generated. Once we connect to it, we will have access to storage files, including the config.txt, which contains the sampling rate of the data logger. Once configured, just unplug the magnet and the board will start automatically switching on and off, recording data from the sensor each time. If we change the sampling frequency, the periodicity will adjust accordingly. But of course, this is just the tip of the iceberg, so we know the basic functionality. Since the last video, I have been having a blast playing with the Sentinel, updating all my sensing gizmos, and tweaking this basic code. It's been a wild ride, for crafting multi-parameter probes to building underwater loggers and even trying it out in my garden irrigation system. Talk about versatility. Developing sensors with Sentinel is now easier than ever, as we have all the required functionalities right in our fingertips. Take the MCU underwater pressure logger for example. It's a budget-friendly, field-ready underwater pressure and temperature logger. While my previous pressure loggers were based on the M0 microprocessor board and individual self-components, now just a single Sentinel board does the trick. And the best part, it can record without a battery change for more than 2 years, and we don't need to open the probe to configure our data downloading, and external model has got that covered. But wait, there is more. You can personalize the code even further to simplify configuration and add additional functionalities. With this new code, you can generate the sensor configuration files directly in the web server, check the voltage of the battery, modify the sampling rate, change the name of the sensor, handy if you have more than one deployed, activate or deactivate it, great for long-time storage, change the name of the login files, or even program at the light start. So grab your thinking cap and let your imagination run wild. The possibilities are endless with Sentinel. I'm absolutely in love with this board, and I hope you have caught the Sentinel fever too. I know, it has been a while since my last video, but I have been up to my elbows in wires and gadgets, testing and developing sensors like a mad scientist. But hey, absence makes the heart grow fonder, right? So here is the big reward for my hiatus. I'm giving away a shiny new Sentinel board. Just drop a comment with your thoughts on this technological marvel and you might just be the lucky one to get your hands on it. And for those of you itching to own this board, I'm planning to put into production. While handcrafting one by one is a labor of love and a tad tedious, we can decrease the price with enough pre-orders. So if you are interested, just shoot me an email. So go ahead, share this video, spill your thoughts in the comments, and hit the subscribe button if you like what you see. Can't wait to see you in the next video.